how we do it. Yeah.
Allô, mesdames et messieurs.
That's how we do it. Keep on rocking.
Yeah.
Okay, how do you put up? So that, does that hook over my ear?
Can turn it off.
Oh, wait, I don't have any place else to hook it
Like this. Yeah.
up. Okay, oh, so that, testing.
Yeah.
Oh, good.
Testing. All right. Welcome, everyone. I am Lane Schwartz, leader of the Neural Polysynthetic Language Modeling team. I am very pleased to introduce to you this morning a member of our team who's going to be giving the plenary talk today. LEVIN is a research professor at Carnegie Mellon University at the Language Technology Institute, LTI. Kevin Knight has an anecdote where he says that you should never try to make a computer do something that you haven't done yourself by hand. To put Lori's career and work on this in context, Lori has 25 years of experience building rule-based machine translation systems, including the multilingual meaning representations, and actually doing that by hand, making multilingual meaning representations work, figuring out the details of exactly how you can engineer that sort of an environment. This talk is going to follow on very nicely from one of the questions at the talk that we just came from the status updates, which is, what is morphophonology? What are morphophonological processes? Lori's going to be giving a talk that will exactly address that question, as well as the related question of morphosyntactic structure and morphosyntactic strategies. So this will be a really nice talk that merges the intersection of that explicitly talks about the intersection of where we all work, which is human language and technology, and talks about that intersection in explicit detail. So without further ado, LEVIN.
Okay, thank you. So I'd just like to find out how many people here identify as electrical engineers? Okay, good. Okay. And how many people here have taken a linguistics course? Oh, that's pretty good too. Okay, good. So I'm basically going to introduce something that I think is important about human language, and that is accessible to everybody and useful in language technologies. So first I want to talk about the superpower of computational linguists. So by computational linguists, I mean the people who are on the neural polysynthetic team. And they can turn unstructured linguistic knowledge into code or annotation schemes. So I'll give a couple of examples. This is an example that has nothing to do with us or our team, but it's something that is not considered to be very linguistic, and it's used in many, many information extraction programs, many DARPA programs, many IARPA programs. It's a markup language for time expressions, and it's something that's critical for most information extraction tasks, event co-reference, entity co-reference, and so on. But where do things like this come from? Well, they come from being able to turn this type of unstructured knowledge, things on specific topics, things on specific languages like Hausa and Spanish, encyclopedias, and fieldwork, and being able to turn that into this, being able to operationalize that unstructured knowledge into this, which is really useful in language technologies. And then to give an example from the neural polysynthetic group, Lonnie, one of the team members, takes unstructured knowledge like this: a single voice feeler next to a morpheme boundary is deleted if it's between two single vowels, blah, blah, blah. And he can turn this into code that has an input-output behavior that you see at the bottom. What's more impressive than that is that I only asked him to extract one little piece of text. The book he's actually working from is this thick. It's more than 1,000 pages. And so he can understand how all of that interacts, all of that unstructured knowledge, and he can turn it into code with an input-output behavior. And this is useful for low-resource languages, and it actually doesn't take very long. It takes a few weeks or months for somebody that knows how to do this. Okay, so what is behind the superpower of computational linguists to turn knowledge from big books into operationalized code? Well, they know what kinds of things happen in human languages. They can recognize those things in languages they haven't looked at before. And they can conceptualize language as a collection of universals and subtypes. So when you get that big 1,000-page book, instead of there being 100 unrelated facts on every page, you recognize it as a system, and you've seen that kind of system before. And then we work with specialized formalisms for coding declarative, not procedural knowledge. The declarative knowledge is then executed by code. And also, just as you probably have a bag of tricks for coding, when you encounter a certain type of problem that you have to write code for, you say, oh, okay, I usually use this kind of technique for this type of problem. We also have our bag of tricks. Okay, so since the title was about morphosyntax, and syntax is grammar, I'm going to start by talking about probably what has been incomprehensible about or unpleasant about grammar to most people. And then I'm going to show that there's a more pleasant way to think about grammar. That's fun. And I'll give a little, so the middle part of the talk will be a little mini tutorial on morphosyntactic strategies, which is, I think, a pleasant and fun way to think about grammar. And then I'll talk about multilingual resources like universal dependency and uniform meaning representation, and how morphosyntactic strategies should play into this major trend in the field and help inform the directions that these should go in. Okay, so the bad reputation of grammar. So if you just look up grammar and you Google images, you get things like this. So notice that they look mean, and they're holding sticks. So they don't look nice at all. And then there are some pictures where they look happy, but they're holding a pen and a chalk instead of a stick, so that's a little bit more friendly. But the stuff on the board is incredibly boring. So then this is a little bit better. I especially like the adverb. She looks really useful. She's got all these tools, and like you get the feeling that you could really do something with this adverb. But there are still bad guys, there's still grammar bad guys, things that nobody likes. This is the run-on sentence, and this is one of my favorite ones that I found on the web. It was about some grammar superheroes, but this guy is dangling participle dude. And so wait, who are you? Says one of the superheroes to the other, because he doesn't even have a mask on. And he says, I'm dangling participle dude. And then she says, everyone's heard of him, but no one actually knows what he does. So some grammar is still presented as obscure and beyond public comprehension, like dangling participle dude. Okay, so now that's how grammar is taught in schools. Now what about how grammar is practiced by linguists? So now you might say, well, okay, so maybe grammar as it's taught in schools is taught by mean ladies with sticks, but, maybe linguists are a bit better. So you go to syntactic theory and you find this, and you think, maybe they're onto something. It's a graph, it's got a lot of pointers, it's formalized, but I don't think I want to learn this today. I'm guessing that that's what the electrical engineers are thinking. I don't think I'll learn this today, maybe not next year either. And so then, okay, maybe a different kind of syntactic theory. And you look at stuff like internal merge, second merge establishes more formal aspects related to edge properties, scope, discourse-related material pegged to a CP, and phase-based theory, this twin BP-CP bit, and you think, I don't think I'm going to learn this today either. Okay, so that's syntactic theory. So at this point, you're saying, we don't really need grammar at all, right? We always want meaning. I mean, that's ultimately what you need to do is natural language understanding. You don't want to end with a grammatical, a diagram of a parse tree. You want to get it meaning. So maybe we don't need grammar at all. Well, yeah, you kind of need grammar because it helps to identify units that are relevant to meaning, like send a text, tells your app what app to activate, the text message app, and then to mom tells the recipient. Or here, in the second sentence, the old man is a meaningful unit, the old man is strong, but here, man is a verb, and the old man is not a meaningful unit. Man the boats is a meaningful unit. So yeah, you kind of need syntax to cut things into pieces that are units of meaning. So now I'm going to present a theory of, this is how I think about grammar, and oddly enough, this is how I teach people to make conlangs, which are sci-fi languages like the ones in Game of Thrones. None of the ones from my conlang class have ever reached that level of fame, but this is how I present human language to people who walk into a class wanting to build a sci-fi language. Okay, so you have the universe and it has infinite shades of meaning. And then you want to say something. And so we have two interlocutors here, the bald interlocutor and the hairy interlocutor. So the bald interlocutor gets the idea that they want to communicate something about this puzzle piece. And the goal is to achieve a common ground, and the common ground is a state where each of the interlocutors have the same pictures in their heads, and they each know that the other has the same picture in their heads. So this is them having the same picture, and this is bald interlocutor knowing that hairy interlocutor has the same picture, and hairy interlocutor knowing that bald interlocutor has the same picture. So that's the state that you want to achieve. And there's all kinds of meaning in the universe, including which spiral arm of the galaxy you're in. But you can't say all of that because what you get to achieve that goal is 7 seconds of air puffs coming out of your mouth. Now, this is either like the greatest achievement of mankind or the stupidest achievement of mankind. 7 seconds of air puffs is what the average utterance is. And it's a pretty big goal. So what has to happen in the 7 seconds of air puffs? Well, they have to be structured as lossy prototypes. So lossy means not containing all the details. And prototypes means typical examples from which you can generalize. And so what we're going to look at is grammar as a system of lossy prototypes for structuring your 7 seconds of air puffs to achieve a communicative goal. The prototypes are pairings of form and meaning, and I'll give a lot of examples about that. And the morphosyntactic strategies are the types of forms and meanings that are paired. Okay, so this is going to be the framework that we're going to be looking at. Okay, and if you want to read more about this approach to grammar, Bill Croft, who's working on the uniform meaning representation, has a new manuscript. He writes a lot of big books. He's very good at that. He's got one called Morphosyntax, Constructions of the World's Languages, and then there's a smaller textbook by Thomas Paine, Analyzing Morphosyntax. And they both basically follow this general approach outlined on this slide. Okay, so morphosyntactic strategies are the result of grammaticalization. So I just want to talk about this for a minute because it's interesting, and it's also important to distinguish what's part of the grammar from what's how, sort of how meaning becomes grammar. So there are two examples here, one from English and one from French. And it turns out that if you want to have some really good reading, this World Lexicon of Grammaticalization is a really fun thing. It basically gives examples of, say, all the languages where go over time became a grammatical marker of future tense, or all the languages where a small thing like a step became a grammatical marker of negation, and it's cataloged. It's kind of fun to read. So if you look at go, you can imagine a time back in history, because grammaticalization happens over long time spans. You can imagine a time back in history where if I was in my dorm room and I were coming here, I could say, I'm going to give a talk. I was actually going somewhere. But now when we say I'm going to read, the meaning of changing location is no longer there. And then along with, and so that's where we say it's become grammaticalized. Its original meaning has been washed out, and further evidence of that is that it can be reduced phonologically to gonna. I'm gonna read. And now it's part of the grammar. It doesn't have the meaning of going anywhere, and it can be phonologically reduced. Now it's turned into a grammatical marker of future tense. In French, they tell me that you don't need to say the ne anymore, that in colloquial spoken French speakers agree with this. You leave ne out a lot of the time. And so at one time, hundreds of years ago, there were lots of small things like a pas, a step, or a mot, a word. I didn't speak, not even a word. I didn't eat, not even a drop. I didn't go, not even a step. And then over time, these words that meant little things that you would add to emphasize, like not even a step, not even one word, not even a drop, over time, those little words began to enter the grammar as negation words. Okay, so morphosyntactic strategies are the result of forms that meaning-bearing elements over long time spans becoming grammatical elements and becoming the conventional way of saying something and losing their original meaning. And that is that's where morphosyntactic strategies come from. Okay, now finally, something you can read, you can understand about grammar, and it's fun. So raise your hand if you've looked at the World Atlas of Language Structures. Okay, that's good. So everybody should just look at the World Atlas of Language Structures all the time. So it's largely about morphosyntactic and morphophonological strategies. So it's got about 200 chapters. They're friendly, they're readable, and there's a database that you can actually use. And so this chapter, for example, shows the order of subject and verb. And you can understand this, unlike the other things from syntactic theory that I showed you. You can actually read this. The map shows the dominant order of subject and verb. Okay, that's clear. And then you get an example. Here's a language with subject before verb, and here's a language with verb before subject. And then you click on the map, and you see that subject before verb, the blue dots are much more common than the red dots, verb before subject, and great, that's something you can understand. And if you're doing cross-lingual, multilingual, cross-lingual parser training, maybe this is something you can use. There's just one thing you have to learn to read this. This thing is called an interlinear gloss. And this is this line here where it has things like PST, PST.3SG. This is how linguists communicate to each other about languages that they don't know. We communicate the information about the grammar through this line here, where we say, well, here's the original language and here's how you would say it in English, but here's a breakdown explaining the grammar of the original language. And you'll notice that this looks a bit like the output of a morphological analyzer like the neural polysynthetic group has been doing. So, okay, so this is a big resource on morphosyntactic strategies, and this is something that's fun and easy to read about linguistics. I'll just mention that in our group in Pittsburgh, we took, I'm looking for Pat, so Pat's not here, right? Oh, Pat, you are here, okay. Pat and other people took the WALS database and other databases and put it into, combined it with many other things and put it into a usable form so that you can have typological embeddings of languages. I just wanted to mention that quickly, and you can download that. Okay. So now that you know that there's a way of looking at grammar that's fun and maybe even interesting, I'm going to give a mini tutorial on morphosyntactic strategies. Knowing about this helps you find your way around a language you don't know instead of treating it as a black box. So the next time you train a multilingual system, instead of just putting the languages in and getting the numbers out, you can actually look at the output and analyze it, because you'll be able to understand languages better, even if you don't know them. Okay, so let's start with form and meaning. We'll start with some meanings that are so basic, you probably take them for granted. These are pictures of an agent acting on a patient. So a fencer kid stabbing a monster in the eye with, okay, so let's say fencer stabs monster, mother kisses baby. Then we have a figure moving against a ground, a skateboarder moving on a ramp, a car moving through a tree, and people moving on a bridge. We have figures located on ground, a book on a table, and a picture on the wall. So I guess cognitively, when you analyze these scenes, you think of them as figures. You identify part of it as the figure and part of it as the ground. So you identify, you don't say that the ramp is moving with respect to the skateboarder. You say that the skateboarder is moving with respect to the ramp. And not that the table is under the book, but the book is on the table. So you kind of make a cognitive thing. You identify a figure and a ground. Now we have something causing emotions. So it turns out that according to the internet, cats are afraid of cucumbers. I don't have personal knowledge of this. It might have something to do with them thinking that cucumbers are snakes. So cucumbers cause fear in cats, and ice cream causes happiness in children. And then another basic meaning, somebody has something, the girl has a book, the baby has a toy. Okay, and these are very basic meanings. These are things that maybe a pre-linguistic child can see, and that and this may be components, even a pre-linguistic child could carve up the world this way, and this could be a way in which a child begins to learn prototypes for grammar. Okay, so let's just first look at agent acting on patient. How do you know whether the dog kissed the cats or the cats kissed the dog? Well, in English, you flip the word order. English is very word order based. If you say the cats kissed the dog, it doesn't mean the same thing as the dog kissed the cats. In Japanese, you use markers on nouns. So this morphosyntactic strategy is called case marking. This morphosyntactic strategy is called word order. And notice that a morphosyntactic strategy is a little bit abstract, so not every language that uses word order uses the same word order. And here, if we say that case marking is a morphosyntactic strategy, it's markers on the nouns, cat and dog, that tell you which one acted on which other one. So this marker tells us that this is the one that was acting. And then in Italian, it's mostly based on word order, but we can also see here this marker on the verb. Oh, I should have lined that up better. But this verb indicates a plural subject, and so it's a marker on the verb that tells you who's acting on who. The plural one, which is the cats, not the dog. The cats are plural, and the verb says the plural one is the agent. Okay, so that helps you sort out that the cats are acting on the dog. So that's 3 different ways that you can sort out which is the agent and which is the patient. So there are a lot of variations on this, but that would scare you away if I started talking about the variations on these themes. They get very complicated. So after you're comfortable and happy with this kind of thing, you can go on to the advanced ones. Okay. So remember that when we had the picture of the universe in the 7 seconds of puffed air, that there's more meaning than form, okay? There's a lot of meaning. And the communication system is a system of lossy prototypes. So you're going to take a lot of meaning and funnel it into a few prototypes. And so all the meanings are going to be competing, a big meaning space, a small prototype space, and all the meanings are going to be competing for spots in this prototype space. And that means that they're going to double use things. You'll find meanings using the same prototypes. So let's look at some examples. So now just from English, if we look at our basic conceptual verb meanings, let's just say that 2 of our prototype spaces are transitive verb with a subject and an object, and intransitive verb with a preposition. So let's just say those are 2 of our prototypes. But we had, I think, 5 or 6 types of meanings, and now we're looking at 2 prototypes. So how are they going to group together? How are these 5 or 6 meanings going to go into these 2 prototypes? So the way it goes in English is, we have agent, transitive verb prototype. We have agent acts on patient. The fencer stabs the monster. Someone has something. The girl has a book. We use the transitive verb prototype. Have isn't really very transitive, but let's say it's transitive for now. And then we could have figure moving against ground. We could use a transitive verb here. The people crossed the bridge. We can also say the people went across the bridge using the other prototype. We could use the transitive verb prototype. So now for our intransitive verb prototype, we have figure moving against ground. The car went through the tree, so it's an intransitive verb went with a prepositional phrase. And we have figure located at ground. The book is on the table. So we have a be verb and a prepositional phrase on the table. Emotion verbs are really weird across languages. They vary a lot across languages. And in English, they use the transitive verb prototype, but they go two ways. Either the experiencer is represented the same way that the actor is as the subject, the cat fears cucumbers, where the experiencer is the subject of the sentence, or the experiencer is represented as something that is affected. Cucumbers frighten the cat. Now, in many languages, intransitive verbs are used for experience. Experiences come to you, so you get an intransitive verb, things please to you. And I want to, on the next slide, go to, so this is about English. So first I want to be sure that it's clear that we have, that if we look at this, is really oversimplifying things, but if we look at this as two prototypes, transitive verb and intransitive verb, we've split something like 6 meanings over 2 prototypes. So we've made a grouping, and that's what we do for English. We've taken a bigger meaning space and funneled it into a smaller prototype space. Okay, so now I want to look across languages to see if they do that the same way. So let's focus on clausal possession, so that sentences like "the girl has a book," which we've put in our transitive verb prototype space. So there are a lot of languages that put possession in the transitive verb prototype space. That is, they represent possession the same way they represent agent acting on patient. And usually in those languages, the verb that means to have came historically from a verb that meant to hold or grasp. So you can see that it went from a much more active meaning. Sometimes it means to see or find. Like if you see it or find it, then you can have it. So it went from a more active meaning, to hold or grasp, but then it became, it kind of washed out to mean possession, but it stayed in the transitive verb prototype space. But we also have possession expressed in many languages as a figure located against a ground. So a horse is at me. So that means I have a horse in that language, but now it's using, in that language, it's not using the grammar of transitive verb, it's using the grammar of the grammar that you use for figure located against ground, instead of the grammar that you use for agent acting on patient. And possession can also be expressed as existence. In this language, so these are from the World Atlas of Language Structures, so you can go back and study this chapter. It's really fascinating. I have a car is expressed as my car exists. So the grammar of existence is being used for the grammar of possession. And this one says, as far as that man is concerned, a house exists, 2 houses exist. Okay, so you can see how languages have taken the same concept of possession and put it into very different parts of the lossy prototype space. Okay, so I've just illustrated this system of meanings falling into a lossy prototype space. I've illustrated that with verb meanings, but I want to give at least a few more examples to show that this pervades language, not just in verb meanings, but in all kinds of meanings in language. So I actually need to see what time it is so that I know how many examples. Okay. Okay, so each example that I'm going to present illustrates differences in morphosyntactic strategies, differences of how the big meaning space falls into the prototype space, and that the clusters of meanings aren't the same in different languages. And also, grammatically relevant meaning, the meanings that determine different grammar, are probably more fine-grained than you realize. Okay, so this is an example from English and Hmong. And the Hmong examples are from my colleague David Mortensen. So these are the grammatically relevant meanings. And what makes them grammatically relevant meanings is that sometimes languages have different grammar for these meanings. We have subquantity of a set, so a subset, some of the set of students. We have possession, a book of mine. Material, a house of bamboo, part of a whole, the top of the tree. Kinship, the mother of that student, and container, a bottle of liquor. Now, all of these meanings go into the prototype space in English. They go into the noun phrase of noun phrase prototype space. They all fall together in English. Because again, there's too much meaning, and it has to fall into this system of lossy prototypes, and it's gonna fall somehow. And it just falls this way in English. But it doesn't fall the same way in Hmong. In Hmong, I think two of these are the same. Okay, so in case you're wondering, CLF is a classifier like a stick of chalk, or if you speak an Asian language, you probably have classifiers, like a sheet of paper, a stick of chalk, a volume of book, maybe a stick of beer, if it's a bottle, I'm not sure, a sheet of pizza. So the classifier is a word like that, and for this word that's spelled IB, the B is a tone marker, and this is the number 1, as in Chinese. So, and N means noun, and so you can see that I think 2 of the patterns are the same, but you can see that these meanings don't fall into the morphosyntactic prototype space. They don't fall the same way they do in English. In English, all the meanings fall into the same prototype form and meaning, whereas they divide up more. What this means, if you're making a universal meaning representation, what this means is that, and honestly, I've had a senior colleague make this mistake, to think that these are all about some kind of possession. The tree has a top, the student has a mother, the liquor has a bottle, and to try to put these all into one meaning space, which is possession, but when you go to other languages, that doesn't work, and you find that the space has to be much more fine-grained. Not sure if I'll skip this one. I think I'll skip that one. Skip that one. Okay, I'm gonna do this one. So it might come as a surprise that the and are not meanings. This is a little bit of a meaning space, and I don't know if there's a language that has different grammar for every point in this space, and of course this space is oversimplified. The and are actually grammaticalizations of part of this space. And this is a really interesting area. Definiteness, the meanings of words like the and is really interesting to study because languages carve up this space really differently. So in English, the word the is outlined here, and the word is outlined here. So for we could say, I'm looking for a student, her name is Chris, and that's a specific student. Or you can say, I'm looking for a student, doesn't matter who it is, but I need one to help me with something. Now, if anyone speaks Farsi or Turkish, you'll know that these are different. These are not grammaticalized the same in Farsi and Turkish, but they are grammaticalized the same in English. And then for the in English, we have the most typical use of a word that means the. Discourse old, I met a student. That's the first time you mention the student. Now the student is discourse old, and then you refer to it as the student. I met a student. The student was tall. But we also have discourse predictable. I went to a wedding, and now that we've invoked the wedding, we can talk about the related things with the. So a wedding introduced with a, but now the bride is predictable. So we use the. So that's discourse predictable. And then we have familiarity based on context. Hand me the pen on the desk. So we don't have to have talked about the pen before, but we can both see it. And then we have uniqueness like the president, the sun. Okay, so that's how English carves up the space. In Hmong and Hausa, Hmong is from Southeast Asia and Hausa is from Africa. The discourse old and discourse predictable use a definite marker, but not the familiarity or uniqueness. So it's a different part of the space than English. And as I said, in Farsi and Turkish, these are, I circled them together, but they're actually marked differently. There's an optional accusative case marker that's used for the specific, but not for the non-specific. And then even English and French, which are in close proximity, use determiners differently for abstract nouns and mass nouns. Glory versus la gloire, and mass nouns, we would just say wine, I drank wine, but du for de, le. Okay, so even English and French differ in part of the space. Okay, so basically that's showing a different carving up of the definiteness space. These are just references of papers, morphosyntactic stuff that I worked on. So I might skip, how much longer should I talk? 10 more minutes? Okay, I'll spend 5 minutes on causality and 5 on universal representations. Okay, so a few years ago, a student picked a really crazy thesis topic, which was annotating causality, such as a hot summer causes devastating fires. And why did we, turns out it's way too hard. Causality is incredibly difficult. It's, you know, the topic of, I don't know, most of philosophy. It's just really hard. So why did we pick it? Because there are a lot of morphosyntactic strategies. There are verbs like impede, there are adverb prepositions like because of, there are conjunctions like so, and adjectives like contingent, so a really wide range of morphosyntactic strategies. It's not rare. In one corpus, 33% of French verbs indicated relations between verbs were causal. So it's not rare, and it's important. And this is the other interesting thing. Hang on a second. Oh, so it's, I'll get back to that in a second. It can be discontinuous. The construction so, that, and then a finite verb. She got so lonely that she decided to watch TV means that being lonely caused watching TV. So the indicators of causality can be discontinuous, not continuous multi-word expressions or single words. So we had a corpus, and people annotated it, and we had, we detected the trigger words, possibly discontinuous constructions, and we detected the, oh dear. Yeah, and we detected other stuff, which part of the sentence was the cause and which part of the sentence was the effect. But this was one of the interesting things that we did that's relevant to morphosyntactic strategies. So here we see the word after. Now again, remember there's a lot of meaning, and a lot of meanings have to fall into the morphosyntactic prototype space in different ways. And this is another example of different things falling together. So after last year's fiasco, everyone is being cautious. So this is temporal. Last year's fiasco happened first, and then everyone is being cautious. But it also, when you read this sentence, it also implies a cause. So we mark this as temporal plus causal. The fiasco caused the caution. But not all temporal things are causal. So in this case, after last year's fiasco, they've rebounded. The fiasco didn't cause the rebound. It's just first the fiasco happened, and then the rebound happened. So what's interesting is what we found out here, if he comes, he'll bring his wife. We don't think that's causal. But if I told you I'd have to kill you, that is causal. Telling you would cause having to kill you. And what's interesting about when you do a corpus study, you find things that you wouldn't normally know. It turns out that 84% of the conditionals also carry causal meaning. So that's an interesting thing about how the two semantic spaces collapse in prototype space. Okay, and we had a lot of these. Okay, there were more of those, but now I'm going to go on to the last part of the talk. And Chris is still here, right? Hi, Krista. Okay, I'm going to talk about you in a second. Okay, if we know what languages have in common, we can build sets of universals, and then when we have a low resource language, we can train on higher resource languages, and we can transfer to low resource languages. But the problem is, these darn morphosyntactic strategies, they make languages look different. And so maybe they need to be neutralized so that languages look the same. So we need to ask that question. Okay, so now I'm really going to go back in time to when I used to work on rule-based machine translation, before statistical machine translation. I, believe it or not, spent, before statistical machine translation and then eventually neural machine translation really took over, I actually spent more than 25 years designing meaning representations and looking at the syntax and the meaning spaces, looking at the meaning spaces and the morphosyntactic spaces of lots of different languages. Okay, so this is called the Vauquois triangle, and at the top we have an abstract representation of meaning. So if I say my name is Lori in English, or mi chiamo Lori in Italian, they have different grammar. I call myself Lori in Italian, and my name is Lori. And you can see, as I've drawn the grammar here, the grammar is quite different. And in the old days, there used to be syntactic transfer systems that would, where people would write rules that say, okay, when you see this structure in Italian, rewrite it as this structure in English in order to translate. And believe it or not, people actually did that by hand. But then, what we normally worked on at Carnegie Mellon was interlingua. So we said, this is in one of our systems for speech translation, one of the earliest speech translation systems. This is, well, mi chiamo Lori, my name is Lori, but the intent, and this is relevant also for things like Amazon Echo, where there are many different ways for the user to express the same intent. This is really the intent of giving personal data, giving a piece of personal data, which in this case is your name. So what I'm gonna show you is that I think you need to watch out for where you are. When you're talking about universal representations, you really need to watch out for where you are. Are you at the bottom of this triangle, or are you at the top, or are you trying to mix things? I want to, and that's some stuff that I worked on. Okay, so I really like Unimorph. I give it a double thumbs up. But I want to, so Unimorph is a universal representation, and it's a big list of, so you've seen in the neural polysynthetic group when they show you output of the morphological analyzer, there's all kinds of morphological tags, absolutive, accusative, present tense, past tense, and Unimorph is a long list of all the things, all the types of morphological tags that happen in human languages. But the question is, can you use it as an interlingua? Can you use it to tell when the meaning is the same? And I'm going to say no. When Unimorph says definite, all it's actually telling you is that the morpheme's most prototypical use is this point in the space. If I look at a language I've never looked at before, and I see a morpheme I've never seen before, and I need to know whether I'm going to call it a definite morpheme. The question I'm going to ask myself is, well, it has a lot of different uses. It probably carves up this space quite a bit. But if its most prototypical use is this point, I'm going to call it a definite morpheme. So unimorph gives us that much information. And it's a really good list of, oh, no, did I? Oh, uh-oh. Is this something I'm doing? Okay. Okay, unimorph gives us that much information, but it doesn't tell us this. It tells us that the English word the and maybe the Hmong or Hausa marker share the same most prototypical point in the space, but it doesn't tell us how they extend through the space. The marker DEF doesn't tell us this. And I'll quickly make one more point about universal dependencies. In universal dependencies, they found that morphosyntactic strategies made trees look different. So here we have I am a teacher in English and Hebrew, and because of morphosyntactic strategies, the trees look different. And here we have I live in Istanbul in English and Turkish, and again, because of morphosyntactic strategies, the trees look different. And so UD evolved then to say, well, you know, it's those darn function words like in and be, and they make it hard and they make languages look different. So let's evolve. And now, although English and Hebrew still look a little bit different, they look more or less the same. So it's an attempt at neutralizing a morphosyntactic strategy. And then English and Turkish now look more similar than they did before, with the morphosyntactic strategies neutralized. The problem is that when they neutralized some of the morphosyntactic strategies, parsing accuracy decreased a little bit. That was training in one language, and so I had a student run a cross-lingual experiment across languages, and yeah, mostly, for most but not all languages, when you neutralize some of the morphosyntactic strategies, thinking, yes, this will help, this will make languages more similar, it doesn't. You lose a little bit. It's because you're mixing where you are in that triangle, mistaking semantics for syntax. Okay, so I'm going to conclude. The grammar of a language is a system of lossy morphosyntactic prototypes for meaning. Languages differ in how the meaning space falls into the prototype space. Don't confuse form with meaning. And when you're making a meaning representation, spend 25 years examining the form-meaning correspondence in many languages so that you know how to design a truly multilingual system. Okay, that's it. Does anyone want to know how to make a conlang using this system?
Okay, so it might be a very naive question. So I assume that there was this whole movement for the perfect language, like 100 or 200 years ago. I'm not particularly certain. And how so my impression from how it ended up is it's not possible from like a logical point of view. How does the interlingua interact, or like is it the final perfect language?
No, you can't do it. So if you look at what they have to look at UMR, And actually, if you look at one of the works of Martin Haspelmath, one of the authors of the World Atlas of Language Structures, you're always going to find, no matter how fine-grained you make your semantic space, you're always going to find a language that makes another distinction that no other language made. And so you can never get to all the semantic distinctions. In terms of syntax, the most typical language is Turkish. If you look in the World Atlas of Language Structures and you look at every map, like we saw on one map, that the languages where subject comes before verb are much more common than the languages where verb comes before subject. Turkish is more typical in every category. So just in case you wanted to know that.
Other questions? Yes.
I just wanted to know how you think we can go about producing data sets that are most useful for the kinds of tasks that you're looking at, balancing perhaps the fact that some languages for which we have a lot of information are typically related to each other and tend not to be very similar. Do you have any ideas for coping with that?
So how to make representations that are the most useful. Oh, so what I would do, okay, so we have things like the World Atlas of Language Structures, and this Lang-Tibet thing that Pat made, and yeah, Pat over there, and there are other papers where people have made embeddings of these features of languages. Like, do they have a word like the? Does the subject come before the verb? And so you make a long, vector of features, and you make embeddings of languages, and then there are different ways to measure which languages are more like other languages. I think that those things are probably useful, but they would have to, I think they should be more fine-grained, and in the beginning, when people started to use the World Atlas of Language Structures, they were using only 6 features, like subject before verb, possessor before noun, and they picked like 6 really obvious ones that they were using. And so I think that they should get more and more fine-grained. The work is headed in the right direction, but should keep going.
Okay.
So, do you distinguish between text and verbal communication in the sense humans are very different when they are talking and when they are writing? And
Yeah.
the syntax is also very different. And sometimes these 7 paths are also augmented with a lot of gestures, a body posture, and things like that. And sometimes even prosody, the same text can have several different meanings based on the prosody and the way it is conveyed. So, what's your approach to that?
Yeah, you're right. You're right to point that out. The 7 seconds of air puffs also comes with gesture, facial expressions, and stuff like that. So it's actually not just the 7 seconds of air puffs. And then when you have text, you can take a lot more space. But yeah, I have worked on both spoken and written language. For spoken language, you end up annotating more, like say you're building something for Amazon Echo, and you end up looking more at like all the different ways to express the same intent. Like, my name is Lori, I'm called Lori, Lori here. You end up looking at slightly different things, but yeah, but yes, thanks for pointing out that it is a bit more complicated than I made it sound.
So, do you think that causality and intent are... Oh, well. Okay. Do you think that causality and intent are kind of intervening? I mean, it's like intent. Well, many people are very interested in intent, trying to understand what's the intention of the speaker when they are talking, and this is a big part for NLU.
Oh, wait, could you repeat the question about causality?
Causality and intent.
Sorry?
Is there any connection between these two?
Connection between,
Causality and intent.
and,
A connection. Is there a connection between causality and intent?
you mean what the, I'm not sure how to answer that. I think they're two different things. Like if you say, one more step and I'll scream, you're expressing causality, and maybe you're also threatening. So I would say, I'm not sure. Yeah, I would say that the intent is somewhat different, but maybe I don't understand the question completely. Or in the examples that I gave were some, let me see if I can flip back to that. Is the question that here, is there an intent to express causality? And here, maybe there's not an intent to express causality?
Well, intent is what the speaker, the human wants to do. So he wants to kill somebody.
Yeah.
And it's caused because of...
Or maybe in the causal sentence, if I told you I'd have to kill you, the intent is don't talk to me. Don't make me tell you.
Right. It could be a threat, it could be a warning, it could be a promise.
So thanks, Laurie, for the great talk. So question now is happening is the meaning that representation should be continuous space or discrete space? What do you think about that? Because this is a good,
Okay, so the team of people that is making the uniform meaning representation, they're obviously going to have to make it a discrete space. And they have I've been on a few of their phone calls. They have really long discussions about how to take something that's obviously not a discrete space and do well enough getting it into a discrete space. If you know a way to put it into a continuous space.
So that was my follow-up question, actually, is, so I teach history of machine translation, and like this idea of that interlinguas have been failing since 1600. That there is no good way of doing it. One thing that I see with the rise of neural networks is the possibility that we may in fact have the potential to get a learned interlingua in the form of semantic vectors, if only we could interpret them. I mean, so what do you think about the possibility of interpretability of these vectors that we're learning?
I don't know that they should be interpretable. Okay, if you learned this as an embedding, it's not interpretable, right? I mean, it's not interpretable as humans practice it. This is really oversimplified, and
Okay. Okay, all right, thank you very much, and thank you.
okay.
All right, time for lunch.
changing. Always rearranging. Always rearranging. Always rearranging. That is constantly changing. Always rearranging. Always rearranging. Changing, always rearranging, always rearranging, always rearranging. That is constantly changing, always rearranging, always rearranging, always rearranging.